Welcome to our technology series presented by DataFluids Labs. In this video, we highlight 12 simple rules and concepts that data analysts and data engineers can easily apply across any data project. We illustrate the example of a real-life project using animated characters. The video explains the benefits of being tool agnostic to enable focusing on real problems and provides a roadmap for problem solving. Meet Devin. Devin and his colleagues brainstorm various options to consolidate data for reports and charts requested by marketing and sales teams. They present their thoughts and finally reach an agreement on the fundamental rules they need to follow.
It's almost the end of the quarter and we still need to build these charts and reports for the marketing and sales team. These are brand new requirements and it will be our first time pulling data for these reports. The good news is, we have the best reporting tools. Also, we just acquired a new ETL tool.
I believe we don't need any tools yet. Let us first speak to someone who understands the data entities and their relationships. How do we know which data to map to? Also, I am not sure if the data is clean and if it needs to be transformed before we present it on the reports. We have no idea how to merge data from multiple systems, because we have never done that here.
I hope we might not need to merge data from multiple systems for these reports. If we need to, then we have the best ETL tools, so we should be okay. The new reports need to display data for a single product line. So apparently it should all come from the same system.
I might not completely agree. You might need to do some data exploration and data profiling before you plan to use a single source for all your reports. You might need to write SQL queries to profile the data and check if the tables you map to really provide the values you need for your reports. SQL will also help you to compare data from other sources and determine which one is better.
Do we really need SQL code here? Because we have the best ETL tools. Most ETL tools today come pre-packaged with data quality modules that automate data profiling and data quality checks and run several tests. We only need to point them to the systems and tables we care about. They have a vast menu of tests they can run.
Unfortunately, processes like ETL and data quality can never be fully automated, so we will always need SQL code. Every data problem we face is unique and SQL provides us the flexibility to write custom queries. We can use SQL to customize our search, sort, and filter data for each unique system or data entity. I wanted to call out that SQL is a standard and is technology agnostic. If we plan to change our tools in the future, we can still continue to rely on the same SQL queries without having to rewrite any code. For this reason, I would like to keep ETL tools separate from SQL code. This separation will keep the process scalable and maintainable. When keeping them separate, we will keep all the complex business rules and transformations logic in SQL queries, and ETL tools will only be used for orchestration. This also makes it easy for engineers to make code changes when they need to because they know where to look. Also, the process will run faster because SQL queries can be compiled on the servers and they hit the data directly without having to go over the network. I see an opportunity here for a major data integration project. We need engineers with excellent SQL skills and deep understanding relational database concepts. I really don't care much about expertise in ETL tools.
So what I am hearing is, SQL code will dominate the ETL and data pipeline engineering work. We will leverage available ETL tools, but mainly for automation and scheduling. The core business rules and transformation logic will always live in the SQL code, and this approach will improve performance, maintainability and scalability of the code. Also, it's important to explore multiple sources of data and determine which ones best map to our reporting needs.
Exactly. The essence of a data integration effort consists in knowing which data entities are involved and what their relationships are. Most teams focus their efforts on data entities and often ignore the aspect of relationships. Also, SQL and SQL joins are fundamental here. Because each time we follow a data entity and its various relationships, we will perform a join operation using primary and foreign keys to match the data and compare. In all relational databases, data is structured in a large number of tables, and therefore, there is a constant need to define joins based on logical relationships between the tables. Joins
are however pretty expensive operations. Especially because our data size is huge and the row count is in billions, joins might crash the server if not defined the correct way. Let's plan to define SQL joins carefully, else they might impact performance and slow down our reports.
I agree, joins can be a bottleneck if not used the correct way or used with the wrong set of joining columns. That is why we need to spend time and do data profiling and manual checks upfront using ad hoc SQL queries. We cannot trust tools to do that for us because each source is unique and there could be a lot of garbage data. ETL tools assume that most of the data being processed is valid.
Then why consider only SQL code to program ETL and data pipelines? Python and Scala programs can do a great job and they might even work better than SQL in some cases. Python and our libraries are a favorite with our data science team. Have you thought about those scenarios?
SQL and Python don't compete with each other, rather they complement each other for developing ETL and data pipelines. SQL is very efficient and fast for data access and retrieval. Python and our libraries, on the other hand, are efficient for data analysis and transformations. We acknowledge these differences and know that they exist. This has inspired big data processing frameworks like Apache Spark to offer both Python and SQL APIs in the form of PySpark and Spark SQL for processing huge datasets. I feel when it comes to data projects, SQL has stronger roots and time-tested standards. But I think we should use both. Is there a limitation that SQL queries including joins work well only for SQL tables and relational databases? Because we have data providers that are not databases. These are web services, REST API, and cloud applications like Salesforce. We also have flat files, Excel sheets, and the big data Hadoop file system. I am not sure if SQL and SQL joins will help us there. The question is, how do we unify those other sources with our databases? There is no limitation that SQL queries including joins work well only for SQL tables and relational databases. Because we have data providers that are not databases. These are web services, REST API, and cloud applications like Salesforce. We also have flat files, Excel sheets, and the big data Hadoop file system. The good news is that SQL and its operations including joins will also support these disparate sources. Well, the main rationale for heavy use of SQL is that it's a standard and is technology and platform agnostic. So it will support regardless of data format or the data storage technology. This means that we can rely on the same or similar syntax, standards, and conventions even when we move data over to a different application. The concept of SQL and all operations related to SQL including joins also apply to data beyond relational databases. We have SQL connectors to Salesforce and cloud applications. SQL is also heavily used for big data ecosystems including Hadoop and Spark.
That is correct. I did read even parallel and distributed computing frameworks like Apache Spark use the concept of SQL joins to merge and combine data from flat files or Parquet files. We can then define SQL table abstractions or views on top of Parquet files and do the match and merge sing SQL joins. It is now clear that SQL and SQL operations including joins are vital for the ETL and data pipelines we need to build for our data integration project. I presume we need to hire a data engineer who can write efficient SQL code and define SQL joins. I know a subject matter expert who understands marketing and sales data. She can walk us through the business rules required for mapping's node transformations.
We also need a data modeler to help us design a single unified data model that represents data entities and their relationships across multiple sources. Because, even though SQL is universally accepted, I feel it is a good idea to stage data from these different systems together into one common storage platform and a single data format. The common platform could be an MPP database or maybe an Amazon S3 bucket on the AWS cloud. We could also consolidate all data into an enterprise data lake. We need to find a storage platform and format that is economical, reliable, and universal. The data modeler also needs to understand the business and data semantics. Considering that we don't have a lot of time to deliver, we might need to build our data team pretty quickly.
Thanks for calling that out. I need to better understand the role of the data modeler and how SQL operations and joins will drive database design and the normalization process for data model.
Database design rules are based on best practices, and database normalization require data to be stored into multiple tables. This division into several tables helps optimize storage, reduce redundancy, and improve data quality. It also makes the process of inserting new data and making updates a lot faster. Because it's more difficult and risky to update a huge wide table than to make updates in smaller tables. I think it would be a good idea to set up a separate meeting for this discussion, because it is really an important topic and needs more time.
Sure, let me schedule a separate meeting for another time. In the meantime, I will request all our viewers to subscribe to this channel and post any questions you have in the comments section. Thank you and happy learning.